This one is no more or less important than anything else we're doing. It just happens to be the most important one we're doing right now. Supporting the crew on orbit is the thing we're doing, but come May 6th, this will be the focus, and this mission, of course, going off well. Of course we want it to do that. Do we expect it to go perfectly? This is the first human flight of the spacecraft. I'm sure we'll find things out. That's why we do this. This is a test flight. So when you do test, you expect to find things, and we expect to find things. But that's what we've done, all those names that I didn't mention earlier, in preparing us to handle any and all conceivable situations, and many of those, because of the training we've had, those situations that we can't conceive of. We're going to be able to handle those as well. So it's not just that Sonny and I is ready. These folks over here are ready to make the decisions that will affect us, and the folks that are in the mission control and those things are ready as well. And we're pumped and excited to be here and go forward.
Just for Steve's pitch, what about the RCS testing this weekend gave you so much confidence in them?
Yeah, good question. What gave us confidence is when we did the test, essentially the thruster performance looked very much like a normal good thruster. Each one of these thrusters was hot-fired at White Sands before the flight, before they got installed in the doghouses, and so when we fired the thrusters, we saw, almost full thrust on every single one. Like I talked about, 3 of them had 100% thrust, and then this way that you can see, how the thrusters performing what I call the chamber pressure was very much in the normal range. And so when we compared that to what we saw on docking day, each of these thrusters were performing, very much nominally. So.
Question for probably Steve. Is the fact that the helium leak levels dropped when you were doing the testing over the weekend provide any guidance on what might be causing the leaks? Does it narrow down any potential root causes in any way? Thanks.
Yeah, thanks. Great question. I think that's what we are in the middle of trying to work out with our engineering teams as we look at the particular systems. What it kind of tells us is there's got to be some kind of effect either from the thermal as the thrusters fire. Obviously, as it creates thrust, it creates some heat that soaks back into the system. And then also there are some sliding surfaces. When each thruster fires, the helium is used it comes into the thruster and then it pushes a couple of valves open so that the propellant, the monomethylhydrazine and then the nitrogen tetroxide can come into the thruster. And so it might mean that those seals wear a little bit and then have some heat effects. It does give us some confidence as we move forward, as we look at this quiescent phase where the leak rates have gone down, that, when we compare what we are going to do on the on-dock period with the rendezvous day in particular, the demand on the thrusters is much, much less. The last really big dynamic activity is the deorbit burn, as Mike talked about. It's a short burn, less than a minute, and so that's giving us some confidence relative to managing the system. But we're really trying to look at the data and understand why did the leak rates change on the docking day? They went up a little bit from what we had. Also, interestingly, in the crew sleep period between the first day of the mission and the docking day, the leak rates didn't change at all in that quiescent period. So we're looking at all that data and trying to figure out if it points to a certain kind of seal or not.
Hi, everybody. Thank you for taking my question. I have a follow-up about those helium valves. I'm curious about whether all of those valves came from the same supplier. And what supplier was that? And did all these valves come from the same lot as well? That kind of question I have.
Yeah, Mark, you want to take that one?
Yeah, these are helium. This is actually not a valve. This is a flange between the thruster and the manifold itself, where there's seals where the helium port is, and we believe that the culprit is in this seal area. So it's really not a valve. So I want to clarify that right off. And we are working with our supplier of this propulsion system. They've been helping us understand this, and help us work through the fault tree to understand, what the potential causes are and how we can remedy this in the future.
Did they all come from the same supplier?
This flange area and these seals, yes, do come from the same supplier and sub-supplier.
Okay, thank you.
Hey, thanks. Question for Steve or Mark. What is the minimum number of thrusters or the slimmest configuration in the propulsion system required to proceed with deorbiting? Thanks.
I think that's a great question, and it's really difficult to answer because each phase of the flight requires certain thrusters, and so we have a flight rule that governs that. For example, during rendezvous, that's probably our highest demand for the redundancy as we approach the ISS. For certainly backing away from station and the undock, it's quite a number of less thrusters required for that. Then for the deorbit burn, it's a number of thrusters required. The OMAX, as we've talked about before, right? One in each doghouse fire to do the excellent burn itself, but then the RCS thrusters provide attitude control. And then after that, there's a number of thrusters that are required to separate the crew module and the service module. And then once the service module separates, it actually spins up and does a disposal burn. And none of the aft thrusters, as a matter of fact, are involved in that process of spinning the service module up and then either separating away from the crew module, spinning it up to a certain RPM, and then doing the disposal burn. So it's hard to give you like a certain number of thrusters because each are required for different events. And so that's one of the things we're looking at very carefully is like what are the demand on the aft thrusters for the remaining part of the flight relative to the separation burns and then the deorbit burn in particular.
Is it not decided yet, or do you guys know and it's just you don't know off the top of your head right now?
I do know for each phase how many thrusters are required. I don't have it with me off the top of my head of each phase what we require. So.
Hi, thanks for taking my question. It's for Steve or Mark. So regarding the helium leaks, is it correct to say you think this is a shared issue causing all the ones you've seen so far? I think before you had said the helium leaks were separate from the thruster issues, but now you think there is a connection. And do we know why they started to appear during flight and not during the ground testing to better understand the first leak that you found ahead of the flight?
I think we've spent some time looking at the two issues to see if they're combined. And when I went and looked at the particular doghouses that we are seeing the leaks in and compared them to where we are seeing the thrusters fail off, they are quite different. Now, the one common thing might be the thruster firings themselves. So, each thruster gets a number of firings in flight, and so what we were seeing is pre-flight on the helium system, we had the one leak, the P2D2 flange leak. Mark's team did an awesome job taking that doghouse cover off and doing a check to look for the helium leakage from various points, and they found only this one area, what we call this P2D2 flange, that leaked. I think the complexity on orbit now is not only do you have the flanges, but there are also some other areas as you actuate each thruster with helium that have some sliding seals that could leak a little bit. And so it appears from the data, at least, that dynamic operations on Flight Day 1, where we fired the OMAX twice for the insertion maneuver and a phasing maneuver, and then also the crew did some attitude maneuvers, part of the operational checkouts that we did, that seemed to create some leaks. And then also after docking, we had two smaller leaks. So they seem to be related a little bit to the rendezvous or thruster firings, and that's why we couldn't see them on the ground. On the ground, all we have is a static system, so we can cycle valves and repressurize the flanges, but that's why we didn't see them on the ground, and we saw them on orbit.
I think I'd add to that, Steve. It's the question, and it's the question that our engineers are asking of themselves, and that's what has gone into the thought process of what other testing do we want to go do while we have the opportunity. That's what drove Saturday's test, and they're just going through the data now so that they can compare all those parameters and determine, is there anything else we want to go do, or is there enough there for us to make this determination? And again, the determination is so we can fix this in the future.
Thank you very much. This is, hang on a second. Take it off speakerphone. This is for Steve. We spent nearly an hour here reviewing problems you guys have had to deal with and all the ongoing work to reduce, the uncertainty in the analysis. What is your overall confidence level in the vehicle at this point? Should we have any realistic concern about these problems in terms of a safe re-entry and landing? Thanks.
Yeah, I think as Mark said, we already have cleared the vehicle for any kind of contingency or an emergency. We would be very confident in putting Butch and Sonny in this vehicle and returning them if we need to. I think we will work through each of these issues, and we will get to a point where we can bring Butch and Sonny back in Starliner. I think we just want a little bit more time to understand what's happened with the data that we have and work through that. Certainly Saturday was a big day of understanding the helium leaks have gone down and also understanding that the thrusters have recovered and that we can count on those thrusters for the remainder of the flight. I think now we're doing the normal business that we typically do of what are the contingencies that could happen between the undock time frame and when we get to the return. How will we manage each of those contingencies should something happen? And then look at the flight rules that we have in place, the procedures we have in place. Are we ready to execute those? And then the same thing with the thrusters, right? If we should lose one of those thrusters, is it acceptable? We don't think we will lose them now based on the confidence we got out of Saturday, but we're kind of going through all that as we get ready to return Butch and Sonny on Starliner.
Question for Steve. Before the launch attempt in May, Boeing said that it was working at peak performance, and before the launch in June, they said all is well. We all obviously understand that this is a test mission and that issues will come up and get resolved. But are you characterizing this as peak performance? And has this been frustrating for NASA? Thanks.
Yeah, I would say, I expected with a test flight that we would learn. I think Mark talked about that prior to the flight, that we would learn something on the flight. I think we've learned on OFT, the uncrewed orbit flight test. We've learned on this flight. We're taking our steps methodically through learning about the vehicle. I think one of the things about the service module, it is a very complicated module. It has lots of thrusters, and I think, their interaction perhaps on the day that you fire the OMAC engines with the RCS system in terms of heat from that system going back into those doghouses and affecting other thrusters. I think that's what we're understanding now during the flight. And so perhaps we could have done different testing on the ground to characterize some of that ahead of time. We did a series of tests called the service module hot fire testing at the White Sands test facility as well. And now we're kind of working through learning about this vehicle, and we're learning about it in a different way. I step back and look at Dragon and SpaceX, and they were able to learn a lot about flying in space with their cargo program ahead of Demo 2. They had many cargo flights they flew to learn and develop their system, and here we are now on our third flight still learning. I'm an engineer. I like to learn, and I think our team likes to learn, and I would not characterize it as frustration. I would characterize it as learning.
Hey, I think this is for Steve Stitch. When you're talking about taking some extra time, to now come home on the 26th to review the data on the thrusters, is this related at all to safety concerns, or is this purely to gather more data and information about the vehicle, given the fact that you're going to lose the service module? I know you said it's clear to come home in an emergency situation, but if it wasn't for this data gathering time, would you feel comfortable having them come home in a sort of non-emergency situation now as well? Thanks.
I think one of the key points really was Saturday hot firing the thrusters. We really wanted to understand those thrusters and the performance of the system by hot firing those thrusters and seeing if they came back. We had, many of us, including myself, had a theory that they were going to return just like on OFC2, and when we hot fired them, we saw the thrust come back. So I think we're taking our extra time, given that this is a crewed vehicle, and we want to make sure that we haven't left any stone unturned. We also want to look at the systems and potential interaction between the systems and make sure we haven't missed something before we return. And we're getting a lot of great data while we're at the space station for not only this flight, but for the next flight. And we're also learning in the process of how to fly the increment flight. If you remember Demo 2, we flew that flight for about 2 months with Bob and Doug. And so I like the fact that the vehicle's staying a little longer. I like the fact that we're watching how the vehicle performs thermally, how the space station charges the batteries. We're getting to see those kind of cycles, which we absolutely need for the increment missions, Starliner 1 and subsequent missions. And we would not be able to get that data on the ground. We would not be able to get this interaction with the space station on the ground. And so I think there's a silver lining in staying a little extra time, and we can learn more about the increment flights and be prepared for Starliner 1 at the right time.
Thank you. And just to follow up on that last question, Steve, just want to be really clear here. You said that, Starliner was cleared to come home in an emergency, but would it be cleared now to come home with the crew? Like, is this a situation that's actively being discussed, whether or not Starliner is comfortable, whether or not Starliner is safe right now to bring a crew home?
Yeah, obviously we wouldn't say Starliner is safe to bring a crew home in an emergency if we didn't feel confident in the vehicle's capability. We're taking a little bit of extra time to work through what we've seen and make sure we have all the plans in place to bring the crew home in a nominal situation for the end of mission. So we're just taking a little more extra time to review all the data and also learn as much as we can while we have this service module in orbit.